Welcome to School of Civil Engineering. In our previous video, I have discussed with you about SDSM user manual, that how can we process data, how can we collect data, and how can we download or predicted data that are very necessary to analysis our rainfall data or temperature data. So as I mentioned in previous video, that I'll discuss about how can we predict about future of rainfall data and minimum and maximum temperature data. So in this video I'll show you that how can we analyze our previous rainfall data to predict our future rainfall condition. I mean, what will be in our rainfall condition after 30 year, after 60 year, after 90 year. This is the probable condition. What will be the change with respect to the present condition. So let's start. As I have told you before, that for SDSM software analysis, the file should be in a specific type. So in my previous video I have discussed about that how can we process the specific type of file for SDSM software. So if you don't see my previous video, please see that. Let's see the data type. I have told you in my previous video that our data should be in DAT file. I mean, our main data or main temperature data or our rainfall data, it should be in DAT format. Here DAT format, DAT file, and we need another file, is predicted file. Its here name is box 033x42y. Its name should be anything, but inside of that there have some predicted data. By using that we'll predict our rainfall data. So I have told you in previous video that how can you download that. If you don't know how to download this file, so you can see my previous video. The link is given description. So before start main work, we need a particular job. At first you have to make a specific folder. I mean, your all file should be in this folder for your work procedure. I mean, it will make your work very easy. So giving this file name like as for YouTube, for YouTube work. So in this file I'll put my wall dot file. I mean, this is my dot file. Copy, paste here, and our predicted file. Copy, paste. So our data is ready for work. After that we have to open SDSM software 4.2. as I am using 4.2, you can use 5 or above version or below version, that's no matter. So after opening SDSM software, we have to change setting. First of all, go to setting, here setting, and then you have to change year length. I mean, from here you have to select the day of your year. So here I'll select 366, and then you have to select the work period. I mean, within which period you work to analysis. This is the important thing, that as I am analyzing my data from 2001 to 2015, so I will give it here 1 on 2000 1 to 2000 2015. On to 2015, and then, and this is very important, and you have to put this date according to your work period. And I think for your work purpose it should be a odd year. Odd year means the number of years should be odd. Okay, why the number of years should be odd, I will discussing next. Then from here, miscellaneous, we have to give the allow negative values, not tick. If here tick, you have to untick here. Even threshold here should be 1 for rainfall. For rainfall you have to give it here 1, and for missing data identifier it will be -999. And one thing I forgot to discuss in previous video, if any data are missing, I mean the data, let me see you. From here, suppose in your data it should be that in some days the data are missing. So here, like here they have no data. For this particular reason you have to change this data to -999. I mean, if anywhere the data is 0, it's okay, but if there have no data, or this dot star sign, then you have to change that in -999, because in a software the missing data identifier, if the software find any data like -999, it will be considered like a missing data. So here our work complete. Then save, okay, and go advanced setting. In advanced setting, model transformation, it should be fourth root, and here other thing will be it will be as usual, it will be also as usual. Okay, and one thing, for optimistic algorithm for rainfall temperature, rainfall analysis, it should be ordinary less a square, and then save it. Okay, back, also. And one thing here, default file directory. In default file directory we have to select the file where we have put our every data. So it's in my case C drive, desktop, user, desktop, SDSM for YouTube. Here you're seeing that the folder I have made, it's here. You have to select it and then save. Okay, back. Then we have to click here, quality control. I mean, we'll check our file. is it okay or not. Quality control, then have to select our file. At first, as we're going to analyzing rainfall, then we have to select this file, open and check. Okay, here we're seeing our total number of day is 5478, and this number showing the number of data within your dates or day. Okay, so our file is okay. Then we have to go skin variables. In here, at first we have to select the file or dart file from rainfall Chittagong, open. Then we have to give our date. It's given as default as we have saved in setting. Then we have to set here annual. And one thing, from predictor variables, then in here for predictor variable we have to select box file, click here, and from box file we have to select, again go box file, and I have to select NCP folder. We have to select double click here, and we'll get here some predictor variables. At first we have to select 11 of them, first 11, 1 2 3 4 5 6 7 8 9 10 11, and here you're seeing that the number of 11, because you'll be unable to find another more than 12 value you can select. So as this total number of predicted values 26, so we'll select first 11, and you can also select 12, it's not in fact. So after selecting this 11 predictor variables, we have to click here. First of all, analyze, then back, then correlation. So here is the main work that we have to find out from here. The first of all, we have to check that p value should be 0 or minimum. And partial r value should be maximum. And we have to select two predictor variable from here, from this 11 data, where the p value should be minimum or 0. It's very good if it's 0 or not 0. We have to take the data which are minimum for p value and maximum for partial r. So from here we are seeing that the first value, obviously they have no 0 value, as the first value is 0, so we'll take that NCP AMS PGL. Be carefully, we have to write it anywhere for our future use. And then after that we have to go back and again deselect that, because we have to select next 11 file here, 2 3 4 5 6 7 8 9 10 11 at 11, again analyze, back, correlation. Here also there have 3 0 value, so we'll take two of them where p value are 0 and partial r are maximum. So we're seeing that the first are NCEPP 500 GL, and for second 0 it's minus 110, and for third 0.097. so from here we'll take first and last value, because here p value are 0, I mean minimum, and partial r are maximum in 2. so we'll take it, we'll write it anywhere. Next, on. So here are two value, the first value and the last value of here, where obviously have to remember that p value will be minimum or 0 and partial value have to be maximum. Then back again and select next. Sorry, have to deselect. Then where here, so we have to again select last remaining 4 data, again analyze, back and correlation. So from here we have to select the value where p is 0 or minimum, here 0.03 or minimum, so we'll select that. So here, then go back, then we have to select our 4 selected predictor variable. Here one is it, second here, third here, and fourth here. So I have selected our 4 predictor variable where p is minimum or p value is minimum or 0 and partial value is partial r is maximum. Again analyze them and correlation. So from here we have to select final 2 data where p value is minimum or 0 and partial r is maximum. So here we're seeing that first and last data are showing that it's minimum p value and partial for minimum value partial r are maximum. So here it's our desired data. So again finally we have to select those 2 data and correlation and analyze. So our skin variable are done. Then we have to go for calibrate model. In calibrate model we have to select our rainfall dot file from here, dot file, and then we have to select a folder for output par file. As I am working with rainfall, so I'll go in rainfall and then rainfall Chittagong. You can give any name for your memorizing. So I am giving rainfall Chittagong, and then here model type will be monthly, and it will be here include here, and process should be conditional, and data period have to be your selected or your observed year. And here we have to select those 2 final predictor variable from NCCP. Here one was NCPP850. First of all, it was first one, and NCCP here was the last. So these are two predictor we have selected. Then we have to calibrate it. It's have calibrated calibration result here. So we have nothing to see here. We'll go back. After that, we have to go scenario generator. Here in scenario generator, we have to change our setting for on time. Here everything will be okay, just we have to change year length is GCM 365 and everything will be okay. Okay, back, and here we have to select the par file we have get from calibrate model portion. So rainfall, here is the par file, open that, and output file. Again we have to select a folder for output file, as we're working with rainfall. So we'll go for here and we'll give the name rainfall to automatically generate. It will be automatically generated as a out file. And here is the most important thing, that we have to select a predictor variable folder from here. So from box we have to select the can ESM2 historical. You have to double click here, historical data folder, and then you can also view that the main data file is rainfall Chittagong, and there have our two predictor variable. And then generate. Have you selected the appropriate number of days in seating for the climatic model? Yes. Wait for some time. Scenario generated, and after scenario generator we have to go summary statistics. Here in summary statistics we have to data source. First we have to select data source, first of all modeled, and then select input file. Here the select input file will be the out file from scenario generation. So rainfall out file, open, and select output file. Here will be our main data file, I mean our prediction file. It will be in text format. So again go here and rainfall Chittagong, as it is model data, so I'll name it model, MODD model. Sorry, model. Open, and here the year will be same as our observe. You can see that, and analyze. Back, here select observe again, and then go to here, as you get a model file, then we need a observe file, obvious means observe file. Okay, so again analyze. Okay, we have get to observe file and model file. So after that we have to go compare result. We have to select both file from there. First of all, you can select any of them, rainfall, observe, and rainfall model. Okay, for rainfall data we have to select from here sum and see here, but so here is our predicted file. We have to copy here and go to the default folder. Oops, sorry, I have deleted it. No problem. For your work rainfall, and you have to open a Excel file. For that file, here is Excel file. Paste it here. Here is our observe file and model file. So save it, minus it, and again open. Mistakenly I have cancel or close SDSM. So after compared result, our first step work finish. Again from here we have taken, again I'm saying you, models sum and observe, sorry, both I have select observe, model sum, and here. So from here it's showing that the blue line, sorry, green line showing that here in the month of January rainfall will be low, and in the month of June, July the rainfall will be maximum. Is that so? We have to compare our future predicted result with this modeled result. I mean from here that with respect to modeled result, how much the future rainfall increasing or decreasing. So back and again go scenario generator. For our next work, again the scenario generator, and we have to change here something. So first of all, go to setting, year length 365 GCM, it will be like that, and data, this is the most important part of here. So we have to change this data range. So what will be the data range for our future predicted? For our future predicted, it should be the range of our total predicted rate. I mean within which year will predict our future rainfall condition. So or will analyze our future rainfall condition. So as my data range was 2001 to 2015, so I will put it here 2000 to 100 and 2016 to 21,000 year. So within this range we can predict our rainfall condition. So here everything will be same like as save, okay, back, then select input file. The input file will be the par file. From here par, and everything will be same like as our past. And from here we have to select from box file, box, this is the, they have two things, RCP CAN CSM2 RCP 45 and CAN CSM2 RCP 85. So we'll use these two predicted file for predict our future rainfall. So first of all we'll select 45, double click 45, so you can see here, and we have to select a folder for our out file. as it was only out Chittagong out, so we'll save it in 4.5 as it was 45, so we'll save it as 4.5. okay, and then yes, generate. Wait for some time. Okay, scenario generated, and then again we have to go for summary statistics and have to select the out file. As we're working for 4.5, so we'll select 4.5. After selecting input file, they have analysis period. Analysis period is the most important part of prediction site. So for prediction, you have to input this date carefully. Suppose I'm going to predict about 2025. So how will input the start date and end date? Analysis start date or analysis end date? As I am working with 15 years data from 2000 on to 2050, so here if I notice that they have a middle value, middle year, and I will find a 7-year next value and 7-year previous value, 7 7 14, and middle is 1, so it will be total 50. So in this like this concept, we'll also select this year. So as I am predicting about 25, so 2025, so I'll select 2018 to 725 and 2032. I think you have understand, and you think, if you think that you have also confusion here, so let me know. I'll try to solve this problem. And then we have to select output file. So select output file. Output file will be here. So our output file will be for Chittagong, rainfall Chittagong 4.5 2025. So open, and a data source will be modeled, then analyze. So here we have taken our reserve file for 2025, and if you want to predict for future, so again you have to do this procedure similarly. Say that you want to predict about 2045. So for 2045, the previous year will be 2038, and it will be 52, and it will be, it is the next half of your observed data, and it is the previous half of your observed data from the point of observation date year 2038 here. And again you have to select from here up to 45, so we're going to have 45, save, open, analyze. Okay, done. So then we have to go compare result. Let's select 4.5 for 25 and Chittagong 45, sum and bar. Here are our data. So copy from here, go to your Excel file and paste it here. Paste here, paste here. So as we have a month here, we'll delete that, and we'll also delete the observe file as it is not necessary. So I will going to show you that, then we have to show it in chart. So if we see it in chart here, chart, select the chart. Here is the chart for our rainfall data. So this line showing the observed period, this line showing the rainfall about 2025, and this line showing rainfall condition about 2045. Here here it's showing temperature increasing, it's also showing temperature increasing, here decreasing, here increasing, here increasing, then decreasing, here decreasing, then increasing. So this is the way to predict future rainfall condition. Now I'm going to show you another one thing, that is for 4.5 or 45, and if we want to do it for 8.5, we have to first select input file, R file, then have to select RCP 8.5 and a output file, rainfall situation 8.5 out, and then generate. So after generate, like a 4.5 or previous output file, we have to do this procedure in same way. And if you think any problem here to do that, please let me know, I'll try to solve it. And thank you very much, and stay connected for next video, cause in next video I'll discuss about rainfall temperature. I'll discuss about temperature data, where the maximum and minimum temperature will be in combined, and I'll discuss it here. So bye.